Hello, friends. Welcome to another insightful episode of TechGig Podcast. I'm Supriti Adavanchi, and today we have a fascinating discussion lined up on a topic that is shaping the future of AI and language technology in India: building efficient and scalable small language models for Indian languages. Joining me today in this conversation is someone who has been at the forefront of this revolution, Ganesh Gopalan, the co founder and CEO of gnani.ai. Welcome to the podcast, Ganesh.
Thank you so much for having me here.
Okay, Ganesh. So let's start by addressing the elephant in the room. India is home to hundreds of languages and dialects. What are the key challenges companies are facing when building small language models for such a diverse linguistic landscape?
Yeah, I think firstly, I think the bigger challenge is more about the large language models or building any sort of models that tend to address the linguistic diversity, like you mentioned. So, as we well know, that every 15 kilometers in India, people speak with a different dialect. Let's assume that people speak Hindi, for example, in say some part of UP. You would find that every 15 kilometers they speak in a different dialect of Hindi. And you would also take a step back and look at migration of people to different cities, and those migrations will have influence of their pronunciations of the same language. I can give you my own example. I'm from Mumbai, but my mother tongue is Tamil, right? And so I have probably influences, though I have the MTI, the mother tongue influence of Tamil, I will also be influenced by my location of birth and the environmental influences around that. Right? And so there are several challenges because typically in the past, right, the models that were available did not cater to each and every language diversity in the country. So that was the fundamental issue with the addressing languages, Indian languages in the context of AI models.
Okay. That's very insightful when we talk of course, the location where we belong as individuals. Now, speaking of training, how do you approach the training SLMs on large audio data sets and billions of Indian language conversations to ensure both scalability and accuracy?
Yeah. So, what we have fundamentally built is a huge annotated database of voice, right? What we are actually talking is dialects belonging to almost every part of India. We have ensured that every district is covered, like I mentioned, the 15-kilometer radius, right? Almost every 15-kilometer radius in the country is covered when we have collected this data through a crowdsourced model. In addition, we do have some techniques on synthetic data that we have also augmented this data. In addition, we have specifically also collected data pertaining to specific domains, pertaining to specific industries that we typically work with. So, in answer to your question, it's important to have the adequate quantum of data. But how we have addressed it is a very large, I would say, data collection where we have collected data across the country to make it the largest annotated data set that is ever collected. Right? We're talking about, I would say, unsupervised, say a few million hours of audio, but also supervised or annotated, I would say rather, a few lakh of hours of audio, right? And because of this, when we augment with the synthetic data and also augment it with the open source data that's available, we then have a very large data set that we can use to train our AI models.
Okay, now that's a very smart way to maximize resources, Ganesh. Can you share some techniques that developers can use to create cost effective yet high performance small language models for Indian languages?
Yeah, so I think now we are into the arena of what we are trying to achieve, right? I mean, are we trying to achieve a problem for addressing the issues with specific industries, right? Now, every industry, for example, while we do have ASRs or speech recognition models for languages that handle any generic conversation. We also do have specific models for say the BFSI sector, the banking and financial services and insurance space. What we have done is obviously augment the generic data with the specific data for that industry, and that's how we built our for example our small language models. Our small language models are built with we started with I think a 1.4 billion parameter model. Currently I think we have a 1.8 billion parameter model for the BFSI industry. So as you can see, it's a very small language model compared to the LLMs that are out there. That uh, look at billions and often trillions of parameters, right? What this enables us to do, because we have a small language model, is to solve problems in the industry in terms of hallucination, accuracy, and latency. And since we do deal with a lot of real-time, use cases, solving for latency and accuracy becomes extremely important. So, what I would like to just say is that depends on the problem that you're trying to solve. Let's assume that you're trying to solve problems for a specific industry. What we have seen is that using some of these small language models is a good solution. Obviously, there are often debates: should you distill a large language model, or should you build your small language model, right? And there are pros and cons in each case, but we have taken the approach of building our own small language models to address and solve problems for a specific industry.
That's a fantastic advice, Ganesh, I must say. Now, speaking of efficiency here, how can developers optimize the SLMs for low resource environments? And what impact does this have on accessibility and scalability in the Indian context?
Yeah, I think low resource requirements. I mean, there are several languages. Let's suppose you're building something for, say, Northeast Indian languages, right? They, for example, tend to be particularly low resource. So you would have to have very efficient data collection, right? But more importantly, you might have to figure out, a good way to, I would say, augment that with synthetic data. More importantly, what you would need is a lot of linguistic experts, and this is something I didn't speak before, but in the course of say solving for say low resource language, often the addition of linguistic experts, for example, who figure out, say you start with a root verb, right? In colloquial terms, what are the kind of ways that that verb can form sentences. Now, this is one thing that we did very early in our you know process when we started building for even languages like Kannada and others, right? But what I would recommend is when you're trying to solve this for low resource languages, this becomes particularly important.
All right. I will just move to the next one. When we talk of the tools and frameworks, what are the kind of recommendations you have for developers to streamline the deployment and integration of small language models into real world applications?
Yeah, so I think there's just plethora of tools and frameworks available, right? And like I said, broadly, if you're solving for a particular use case or a set of, say, some problems in a specific industry, you have two options: distilling a large language model or doing a small language model. Okay. Now, once you are done with making that choice, right? Now there are several open source algorithms available, which you can then go ahead and choose, right? For example, bunch of things around land chain, land graph that you can use to build like agentic models. So depending on what kind of models that you're building, is a decision for you to take. Let's assume that you're building a agentic framework, right? What we found is a lot of very interesting options out there, or you can even, if you're very adventurous enough, uh, you know, build on your own or even modify something out there, right? For example, like they give you a few examples of land chain, and again for agentic, for using multi-agent, models. We found, for example, land graph to be a very good option, right? So there are, but you will have to go ahead and test the various options out there and make your choice depending on your use case and on your domain, your problem that you're solving, and take a call. So, but I would broadly recommend, taking a uh, say when you're starting to solve a problem, try to do it with something that is more easily available. It could even be an open AI. It could be a it could be in some open source model, right? So that you solve and find out whether you have product market fit, whether you have the right customers that you are able to get for that solution that you have, and then go ahead and re-engineer your platform with the right engineering. If necessary, build some of your own models, take something, experiment with a bunch of open source models out there and take your choice. When given, when you're building, for example, say a small language model, to give you an example, we had a bunch of options, right? For example, initially we thought we would take, in order to solve our problems, we thought we could even, we don't even need a small language model. We can start with an open AI, right? But then we found that it doesn't solve our problem for various reasons. Then we said we will try to take some, open source model. Say, I think we tried Llama 3.2 or something, and fine tune that to try to solve it. In our case, because we're trying to solve this for Indian languages, again, this approach also did not succeed too well. And that's when we decided to go for more of a foundational model to solve this. Again, there are once you have taken that choice, again, for example, you can use NVIDIA's framework, for example, the Nemo framework, to go ahead and build this, or there are various other options, or you can build again without a framework on your own, build out some of these models. So broadly, the approach that I would line up is find out your product market fit by what is the fastest to build. In your case, depending on the skills you have in your team, could be a Llama 3.2 fine-tuned, or it could be some even call APIs from OpenAI if that's what you want to do. Figure out the whether you're solving the problem, and then go and re-engineer with the right tools to make it.
Fantastic insights, Ganesh. Now, as we wrap up, how do you see the future of small language models evolving in India, and what role will developers play in shaping this transformation?
So I think this is very important. The reason why we are particularly drawn towards small language models is that to solve problems for an industry, uh, we even today feel that it is good to keep the domain restricted to lower the hallucinations, and especially if you're solving for real-time applications, extremely important to for you to have a smaller model so that the latencies are tightly controlled, right? And multiple options for you to make this happen, but we like I told you, we have taken the call to go with small language models to solve for specific industries, and it's a path that has given us good success in terms of accuracy, lower latency, and so on and so forth. What we have also done is sometimes you need to augment that with some of your other technologies. We have also built a voice-to-voice LLM, and when we augment, small language model with our voice-to-voice LLM, we've seen good successes, especially on, for example, building autonomous voice AI agents, for the enterprise, right? And so I would recommend, this discussion obviously is a little more broader from an AI perspective. But what I would like to say is that, go ahead and build, quickly, and uh, once you are on the path of small language models, as we have discovered, are a very good option to solve problems in industry for various reasons: accuracy, and also latency, but more importantly, also sometimes cost becomes a very important issue, right? And of course, the control on the model per se. So when you're dealing with enterprise, often there would be a lot of demands on accuracy, and if you don't have control of the model and you just have APIs to call, you're going to fall short in satisfying that customer. So best of luck in your journey, whether you're embarking on SLMs or any other AI models. Like I said, there's a plethora of options out there. We've taken the foundational approach for SLMs, but that need not necessarily be the only choice in the market.
That's a fantastic note to end this conversation, Ganesh. Thank you so much for sharing your expertise with us today. It's been an eye-opening discussion on how we can take small language models more efficient, scalable, and accessible for Indian languages.
Thank you very much for having us.
Absolutely. And to our listeners, thank you so much for tuning in. If you found this episode valuable, don't forget to subscribe and share your thoughts. Until next time, stay curious and keep innovating. Thank you so much, Ganesh, once again.
Thank you.